Right now, imagine the exact spot you're standing on. Beneath your feet isn't just soil. There are kilometers of solid rock, oceans of molten metal, and at the very center, something almost as hot as the surface of the sun. Now imagine someone says, "What if we just keep digging all the way down?" That's not science fiction. In the 1970s, the Soviet Union actually tried it. They drilled deeper than the deepest ocean trench, deeper than Mount Everest is tall. And what they found surprised even scientists. But here is the most unsettling part. The deepest hole humans have ever drilled is only 0.2% of the way to the center of the Earth. So what would happen if we didn't stop? Let's go down. The crust, the thin skin we live on. If we start digging, the temperature begins rising almost immediately. At just 50 meters down, it gets warmer. On average, for every kilometer deeper, it increases by about 25 degrees Celsius. We are currently in the Earth's crust, the outermost layer. Under continents, it's usually about 30 to 40 kilometers thick. Compared to the whole planet, that's thinner than the skin of an apple. Down here are layers of rock, ancient fossils, metals, and minerals. Humans have built incredible things underground. Particle physics labs studying dark matter, massive nuclear bunkers, some of the deepest mines ever constructed. But without protection, we'd already be crushed by pressure and cooked by heat. So let's imagine we have an indestructible drill, the deepest hole ever made. At 12.2 kilometers, we reach the deepest point humans have ever drilled, the Kola Superdeep Borehole. It took Soviet scientists nearly 20 years to get there. No one went down. Everything was remotely operated. And what they discovered changed assumptions about Earth. They found microscopic fossils nearly 2 billion years old. And even more surprising, they found water much deeper than scientists thought possible. But the deeper they drilled, the harder it became. Temperatures reached nearly 180 degrees Celsius. The rock didn't behave like solid stone anymore. It started acting almost plastic. And repeatedly, the borehole collapsed. Eventually, they stopped. But we are not stopping. The mantle, solid rock that flows. Around 40 kilometers down, we leave the crust and enter the mantle. Here's where things get strange. The rock is technically solid, but because of extreme heat and pressure, it behaves like very thick, slow-moving plastic. Even though temperatures exceed 1,300 degrees Celsius, the pressure prevents it from fully melting. Instead, it flows, slowly, over millions of years. These slow convection currents drive volcanic eruptions, earthquakes, and the movement of continents. But here's the obvious question. If we've only drilled 12 kilometers, how do we know any of this? Earthquakes, our planet's X-ray machine. The answer is earthquakes. When an earthquake happens, it sends seismic waves through the planet. There are two main types, P waves, which travel through solids and liquids, and S waves, which can only travel through solids. Scientists noticed something strange. On the opposite side of the planet, S waves disappear, which means there must be a liquid layer blocking them. That's how we discovered the outer core. The outer core, the metal ocean that protects life. Now we are in a swirling ocean of molten iron and nickel. Temperature, over 4,000 degrees Celsius. This moving liquid metal generates powerful electric currents. Those currents create Earth's magnetic field. Without it, solar radiation would strip away our atmosphere. Life as we know it would not exist. And it gets even stranger. Earth's magnetic field doesn't stay stable forever. It flips. North becomes south. South becomes north. We know this because when lava cools on the ocean floor, it locks in a magnetic record, like a barcode of Earth's magnetic history. The last major reversal happened about 780,000 years ago. When will it flip again? No one knows. The inner core, a solid sun-hot sphere. At the very center of Earth lies a solid sphere of iron. It's nearly as hot as the sun's surface. So why isn't it liquid? Because the pressure is so extreme, more than 3.6 million times surface pressure, that iron atoms can move. Even more surprising, recent research suggests the inner core doesn't rotate at exactly the same speed as the rest of the planet. It appears to speed up and slow down on roughly a 70-year cycle. Some scientists even suspect there could be an inner core, a slightly different structure at the very center. We are not certain yet. We are still investigating. The real story. We will probably never physically reach the center of Earth, but using vibrations, physics, and mathematics, we've mapped a place no human will ever visit. We are a species trapped on the surface of our own planet. And yet, through curiosity alone, we've uncovered the hidden structure beneath our feet. And that might be the most incredible story of all.